Hi, I'm Sudeep, and today I'm going to present about one of the concepts from chapter 19, remote file access and cache consistency in distributed systems. Let's talk about the problem statement. Um, as we know, in the past, centralized systems required frequent communication with a central server for file access, and that led to significant network traffic and slow data retrieval. With all data requests directed to one central server, it led to some delays and even some server overload. Uh, and in addition to that, cache inconsistency was another problem. So that's why we have come up with our problem statement. And let's talk about our objectives. So the main objective of modern distributed systems is to solve the issue of high network traffic and slow data retrieval. We reduce the need for repeated data requests to central server by storing frequently accessed data in local caches, and that ultimately speeds up access time of data. And caching also improves performance and reduces the load on the network. There's another challenge that we need to address, that is cache consistency. The technology that the data cached on multiple machines remains in sync with server's master copy is even if changes are made on different nodes. This consistency is very crucial to maintain the integrity of the data across systems. Let's talk about some of the studies that we did. Uh, Before the introduction of distributed caching, systems used to rely on a centralized approach to data access. Every time a user needed data, it has to be fetched from the server, even if it had been accessed very recently. This design led to poor performance, high latency, and also unnecessary network uses. The lack of local storage or caching resulted in servers being overloaded with requests, especially if the system is very large. um, some of the early attempts at solving cache consistency involve approaches like client-initiated validity checks, where clients would ask the server to verify if the local cached copy was still up to date, was new or not. While this helped, it was not very efficient of when the environment was getting high traffic. In more some of the more advanced systems, some designs employed server-initiated cache invalidation, where server would track cache copies and actively push updates to clients. But this approach had also some limitations. Some early research showed that caching data locally could significantly reduce access time and server load. There was also another challenge to keep the data synchronous. So after studying about modern distributed systems, the results that we came up with are: okay, modern distributed systems have made significant strides in improving performance and reliability by introducing two main cache consistency strategies, that are write through and delayed write back strategy. These strategies aim to keep the cached copies and master copy in sync while optimizing the performance. With write through approach, data returned to the cache is immediately returned back to the server. But this ensures data consistency. It can also slow down the overall system because every write operation involves both the cache and the server. It is a very reliable method, but it can lead to performance bottleneck if there are frequent write operations. Next one, delayed write or write back caching allows the data to be returned only to the cache initially, and those changes are then added to server later. Either either they are added periodically or when the file is closed. This method significantly improves write performance, as the system doesn't need to wait for server confirmation. but it also comes with a risk. If a machine crashes before the changes are written, um, then those changes might be lost. These approaches are typically combined with cache flushing techniques such as scanning the cache periodically to ensure data is correctly synced. Compared to older systems, more traditional systems, where data consistency was used to be handled manually and errors were more frequent, modern caching systems are very efficient by because they use both caching and consistency protocols. The network traffic is also reduced and access time is faster and data is kept up to date with less limitations. Next up, so these are our results mm, with modern distributed systems. So what are the benefits of modern distributed systems over traditional systems? We talked about that, and uh, in conclusion of our presentation, we would say remote file access in distributed system has seen tremendous improvements over older centralized approaches. Um, These systems have dramatically reduced network traffic. They have improved access speed by utilizing these caching mechanism and cache consistency protocols. So the introduction of write-through and delayed write strategies have also allowed for better performance and reliability in terms of both data consistency and access time. Traditional systems that more traditional systems used to suffer from slow retrieval, high traffic, and inconsistent data. They have been replaced by more efficient solutions that scale well as the demand grows. So gas consistency remains an important challenge, but modern techniques ensure that these data remain accurate across the system. Some of the systems like SDFS, GFS are some of the examples how these concepts are applied at scale. In the future, with continued advancement, these caching and consistency data retrieval distributed systems will continue to provide even more reliable and faster solutions for data access. So for this topic, I would like to thank my professor, Mr. Wims, for providing all the resources and also operating systems concept book, which was in the course content from which I've gained this knowledge and I've created this presentation. Thank you.